Let's look please at page 305, problem number 39. Problem 39. It says that in a study of the speed of blood flow in artificial heart valves is the following statement. So H naught mu equals 5.0, X bar equals 5.96, T, and I'm going to call it T star, equals to 2.59 on 47 degrees of freedom, and P equals 0.0049. Alright. It says, translate this sentence in English. And part B, what does the statement tell us about this type of heart valve? Well, alright. there's some gobbledygook there. And let's try to make some sense of it. The null hypothesis, 5.0, is saying that the average rate of blood flow for these artificial heart valves in the population of heart valves is 5.0. That's the population mean assumption. Now, the alternative hypothesis, would it be greater than 5.0 or less than 5.0? Well, let's look at our mean. Our sample mean was greater, so the alternative hypothesis was greater than 5.0 because that's what the data shows. There's a higher blood flow level. That's what it's called, right? Speed of blood flow. Speed of blood flow. Okay, in artificial heart valves. Well, what are they trying to do here? Okay, well, suppose you're a manufacturer and you manufacture artificial heart valves, and the industry standard specifies that the average flow rate in these heart valves has to be at least 5.0. That's a standard that is going to be set. If they're not up to 5.0 on average, then they're not going to be. We're not going to use them. Okay, they're heart valves. So the artificial heart valves. Well, you might think of that. All right, I'm the manufacturer. I'm going to make a claim that my artificial heart valves, the speed of blood flow is always going to be greater than 5.0. Do I have enough evidence to show that? Well, here we took a sample and got a mean of 5.96, which was higher than 5.0. And what was the size of the sample? From the degrees of freedom, the size of the sample would be N is 48. 48. So they went through and they tested 48 artificial heart valves for the speed of blood flow. Okay, whatever that means. And they tested 48 of them, sample 48, which is one more than the degrees of freedom. They found the mean was 5.96. Now, we're going to test to see if this mean is significantly different than that number. So this is our standard for comparison, and this is what we're testing to see, is this number much higher than 5.0? Now think about another type of scenario here. Suppose that X bar was 5.01, just barely above 5.0. 5.01. For all practical purposes, it's the same, isn't it? 5.01, probably due to random fluctuations. And in fact, when we do the hypothesis test, we will find that's the case. There's not enough evidence to show that 5.01 is statistically significantly different than 5.0. We're not likely to find that. However, this number probably is. It's pretty high compared to 5. But now I'm talking subjective here because we haven't done the calculation yet. Where do you draw the line? Where is this number going to be large enough so that we now consider it to be statistically higher, significantly higher, rather than just due to random chance? I don't know what that number is, where the break point is. But we have information here to check this number. And so the t-score was 2.59, and that basically means that this result, compared to that result, is about 2.59 standard deviations apart. Remember, the standard deviation is a yardstick that we use to measure differences between two numbers, in this case between two means. All right, finally, there's a p-value, 0.0049. Again, a very small p-value means that the probability of being wrong and rejecting the null hypothesis is very small. In this case, less than 0.5%. Less than 0.0049 is less than 0.5%. So we would reject the null hypothesis in favor of the alternative with 99.51% confidence. And just for good measure, let's add in that p was equal to 0.0049. All right, so that could be easily be a conclusion for this problem. Well, it would be the conclusion that we would reject the null hypothesis, because no statistician out there would do anything but reject the null hypothesis for such a small p-value. All right, so the data shows that the heart valves are definitely higher than 5.0. All is good. The world is safe. So that's that problem there. So, I'll raise some board. We'll do another problem.